Welcome to two examples of adding and subtracting rational expressions with unlike monomial denominators. The main thing to remember is that when adding fractions or rational expressions, we must have a common denominator in order to add or subtract the fractions. So looking at our first example, the first step is to determine what the least common denominator would be if we have a denominator of 5x and 3x. And if we're not able to look at this and tell the least common denominator would be 15x, it's often helpful to write the denominators in prime factored form. What I mean by that is we can write this as 3 over, instead of 5x, 5 times x. And instead of 2 over 3x, we can write 2 over 3 times x. So another way to think of finding a common denominator is just to make sure the denominators contain the same factors. If they contain the same factors, then we'll have a common denominator. So for example, notice how this second fraction here has a factor of 3 in the denominator, but this fraction doesn't, which means this denominator needs a factor of 3 in order to obtain a common denominator. And we can multiply the denominator by 3 as long as we do the same to the numerator. Remember, 3 over 3 is equal to 1. So this is like multiplying by 1. And then looking at the second fraction, notice how it does not contain a factor of 5 in the denominator like this fraction does. So this denominator needs a factor of 5, so we can multiply this by 5 as long as we do the same to the numerator. Again, this is like multiplying by 1. Notice now our denominators contain the same factors, and we've obtained our common denominator. So now we're going to multiply these, and then we'll add. So this first fraction is now 9 over 15x, and the second fraction is now 10 over 15x. Now that we have a common denominator, the denominator is going to stay the same, and we add the numerators. Well, 9 plus 10 is equal to 19. Once we find the sum, we do want to check to see if the fraction is going to simplify, but since 19 and 15x don't share any common factors other than 1, this is our simplified sum. Let's take a look at a second example. Again, the first step is to determine the least common denominator, or at least a common denominator. And again, if we can look at this and tell the least common denominator would be 36x squared, that's great. But if we can't, again, it's going to be helpful to look at the prime factorization of the denominators. So for this first fraction, let's determine the prime factorization of 12. Well, 12 is equal to 4 times 3. 4 is equal to 2 times 2. So we can write 12x squared as 2 times 2 times 3. Now notice how both denominators already contain x squared. So we'll go ahead and write times x squared here, minus 2 all over, well, the prime factorization of 9 is just 3 times 3. So we can write this as 3 times x squared. Now we need to make sure the denominators contain the same number of each factor. So for example, looking at this first fraction, notice how it only contains one factor of 3, but this denominator contains two factors of 3. So we need one more factor of 3 here. Again, multiply both the top and bottom by 3. Then looking at the second fraction, notice how it doesn't contain any factors of 2, but this denominator contains two factors of 2. So we have to multiply the denominator by 2 times 2, as well as the numerator. Now if we compare the denominators, notice how they both contain two factors of 2, two factors of 3, and two factors of x. So now we have our least common denominator, so we're going to multiply and then we'll subtract. So this first fraction is now 15 all over 2 times 2 times 3, that was 12, times 3, there's the 36. Then we have x squared, minus, here we have 2 times 2 times 2, that's 8, all over another 36x squared. Our denominators are now the same, so now we can go ahead and subtract. The denominator stays the same, and the numerator is 15 minus 8, which is 7. And again, we should check to see if this simplifies, but it doesn't, so we're done. Okay, I hope you found these two examples helpful.